Alright, so here we are with the 1-6 day 1 solving for a variable notes. So the idea is that you're going to be given an equation with a lot of letters in it, or variables, and you are going to want to solve for certain variables. So we're going to solve an equation in 2 or more variables for one of those variables. Very interesting set of words there. So, when it comes to solving for a variable, we need to realize that most of these are going to be formulas. So formulas are equations that state a rule for a relationship among quantities. For instance, if you want to talk about converting Fahrenheit to Celsius, there's this formula that goes through that. If you want to find the area of a circle, for instance, you get pi r squared. And so you'll notice that unless there's maybe a tiny operation going on, most of the time there ends up being a lot of letters and symbols going on. And so because of that, most of the time, for instance, you want to find the area of a formula, of a circle. However, sometimes you actually are given the area and want to find the radius. And so because of that, you may actually end up solving backwards. And so we're just going to do that anyway and be able to say that the radius is actually going to be the square root of the area divided by the radius. Is that what it is? Divided by pi. Area divided by pi square rooted. Just double checking for fun. Okay. So, yep, that's what it is. Anyway, so you won't have to do ones like that at this point, but we are going to have to undo certain operations. So for instance, the formula D equals RT. D is what we call isolated, meaning alone. And so the idea is that you're going to be told which variable you're going to solve for, meaning which variable are you trying to get alone, and you're going to rearrange all of these ideas in the formula to isolate that variable. So we're going to use a bunch of inverse operations to move things across the equals sign. All right. So in order to solve for a variable, which is what we're doing here, we're going to locate the variable that you're asked to solve for the equation. So that's our first step. Find out what it is they want you to solve for. Once you do that, you then identify all of the operations that are happening to this variable. So for instance, it might be multiplied by a number, it might be multiplied by a letter, whatever it happens to be, identify what's happening to it and the order it happens, and then use the inverse operations to undo all of those. So if you saw something being multiplied, you'd undo that, of course, by dividing. So we'll try one of those over here. So it turns out that actually the way that they get pi is by taking the circumference of a circle and dividing it by its diameter. Now, of course, you can actually do this at home. You can measure the circumference of anything that's a circle and then measure its diameter. The problem is that to accurately measure a circumference and accurately measure a diameter, you do need first of all, different measuring tools, and of course diameter, you'd need to know where the center of your circle is. So there's kind of a lot of things that could make it not necessarily 3.14 when you solve, but the idea is the same. What we're doing here is identifying that pi is the thing we're solving for, and so I need to undo everything so that I can finally get pi equal to whatever it's alone equal to. So I first identify what's happening other than the variable, and what's happening to the variable is that it's being multiplied by d. So if it's being multiplied by d, then I need to undo step 1, and so we're going to divide by d. So that means that to both sides I'm going to divide by d, and that's where we might get something like a fraction. So it turns out that pi is actually equal to the circumference of whatever circle it is divided by that same circle's diameter. So if you want to calculate some pi, take circumference, divide by d, there it is. And so again, that's undoing each of what's happening in order to isolate a variable. All right. The next slide here, we have an example or application. So a student finds that they can, that a can has a circumference of 22 centimeters and a diameter of 7 centimeters. And so what is their estimation of pi? So remember that we just decided that pi is actually the circumference divided by the diameter. And so if we want to find their estimation based on their ability to measure things, we would replace C, or circumference, with 22 centimeters, and D, or diameter, with 7, and we'd get an approximation of pi, which is 22 over 7, which is actually a very common assumption of pi, is 22 over 7, because it is kind of the closest whole number fraction that actually very closely relates to pi. In fact, you get 3.142857. Either way, if you didn't know, pi is actually 3.14159. So you can kind of see that it's getting a little off starting at this decimal. But on that note, that is their approximation of pi, which for most of what we do ends up being 3.14, and so you don't really need a whole lot of the decimals after that when it comes to the end. All right, so we're going to go ahead and do these two examples. I know it says lesson quiz, but we'll just say lesson review. Sounds good. And so the lesson review here is to solve for C given what we have here. So I have P equals R minus this C. And so to get C by itself, I need to undo the R that's there. This gets a little tricky because as much as you'd want to add an R, the R is actually already positive, right? It's not a negative out front. So to move that R over, I actually subtract. So I'm going to subtract R to both sides, which means that we'll have actually P minus R equal to negative C. Of course, C is not alone by itself yet, and so we need to take that imaginary 1 that is being multiplied by that C and divide it out. So if we divide a negative 1, this is also where fractions and division are not very fun, but basically you need to divide everything by a negative 1. Otherwise you end up with a different result. So if we divide everything on this side by negative 1, we get C. And if we divide everything on this side by negative 1, basically you're just changing each of this numerator's signs. So instead of a positive P, we end up with a negative P. And instead of a negative R, we end up with a positive R. So I'm not sure what C and P and R equal or reference in this example, but C all by itself is equal to negative P plus R. The next one, I'll move over here a little bit. Notice that we are solving for y, and so that means that we have 2x plus 7, but y is the thing we're trying to find, equals 14. So I need to move everything that's over here, this 7, this 2x, to the other side so that y is all by itself. In order to do that, you can see what's happening to the y. It's being multiplied by 7. And then it's being added to 2x. And so in order to solve this, we want to go backwards of these steps. So instead of adding 2x, I'm going to subtract 2x. So over here, I'm going to subtract 2x. Remember, this is a positive 2x, so we'll subtract that chunk over. And so we end up with 7y equal to 14 minus 2x. And then as we did before with this negative 1, we are going to end up dividing the thing that's being multiplied here. So I'm going to divide everything by 7. And remember that means each individual piece as well by 7. And so we end up with y by itself, and then it's going to equal the simplification here of 14 over 7, which is 2. And then depending on how you want to write this, you can just write minus 2x over 7. But the nicer way of writing that is actually as its own fraction. Whoops. Of negative 2/7, and then the x next to that. In fact, the even nicer way is to have the x piece first, and then the number, because hopefully that is something that you recognize as maybe a linear equation, which is what we'll be working through a lot of very soon. So again, those were kind of challenge problems to see if we could apply what we saw. The first one was kind of a one step, but it had that second negative step. And then this last one here was kind of referencing to something we'll be doing later, which is linear equations. So what you're going to do on your homework assignment is a bunch of 1- and 2-step rewriting equations. So again, just as we said, go ahead and identify the variable that you're trying to solve for, and then undo all of those operations. So again, referencing that solving for a variable set of steps. All right.